First, I'm going to mark a line with a pencil on the TLC plate that shows where I'm going to start to post the dot. I'll do this 1 centimeter above the bottom of the TLC. Now I'm going to start placing the dyes on the TLC plate using one of these capillary tubes. Now that we've put all the dots on the TLC plate at an evenly spaced intervals, we can begin the chromatography. We have a diagram in our notebook over here that shows which values, or which dyes are used at each of the different dots. Now that we've been allowing our solvent to rest in the beaker to establish equilibrium, we can remove the wrap from the beaker and place the plate into the solvent. We need to make sure that the solvent level does not actually touch the bottom of the dots and that the TLC plate will stand up completely in the beaker. Now we'll wait a few minutes for the chromatography to take place and the solvent to rise up towards the top of the TLC plate.
It's now reached equilibrium, sticking the plate into the liquid so it can touch the dots.
The beaker has reached equilibrium, so now I'm sticking the plate in and not letting the solution touch the dots.
Now that we've let our solvent reach equilibrium, I will now place the plate in the solution without touching the dots.
So now that we've finished the chromatography, we can go ahead and remove the plate from the beaker. First thing we need to do now is measure the solvent line. 0.5 centimeters. Now I'll measure each one of the dots, see how far it is from the line where it started, and I'll use this measurement to determine the retention factor. So for this first dot, which is the unknown 132, I'll measure the distance from the line where it started, and we're going to be measuring halfway between these two dots, which would be right about here, so we're going to call that 2.9 centimeters. So now to get the retention value, I'm going to divide this value by the solvent distance. That would be 2.9 centimeters divided by 5.5 centimeters, which is a value of 0.527.
Taking the plate out, checking to see the solvent line is not at the top, so I can measure between the dots and the solvent line. 6 centimeters. 4.8 centimeters.
Now that we've let it sit in solvent, we'll remove the plate. Then we will draw a line as to how far the solvent went. And now we'll measure from our solvent line to our starting point. 5.9 centimeters. Alright, now I'm going to measure from the center of the dot. Which is 5.5 centimeters, and I take that measurement and divide it by my solvent line to get my retention factor. I did the exact same thing. I'll
measure this, measure the distance for this dot from the center of the dot, from this line. And it comes out to 5.5 centimeters. Now divide that by the distance on the solvent line.
Here's a table of our data that we collected. This shows the RF values for each of the 7 dyes that we used, including the 2 unknowns, for each of our 3 solvents, 1, 2, and 3. From these dyes, we determined that unknown 1, 2, 3 is formed from the basic fluxion and methylene blue, and the unknown 4, 2, 1 is formed from the fluorescein and methylene blue.